Hello students, welcome to Inside Physics. This is Srinivas. Today we will derive equations for electric intensity due to a dipole. Okay, see, this is a topic which is very important regarding intermediate board exams. It may be asked as a short question in intermediate board exams. So here is what we will derive: electric intensity due to a dipole on axial line and on equatorial line. So what is a dipole? In previous classes we have discussed a combination of two dissimilar charges placed a distance apart, that means a distance in between them is called a dipole. So due to this dipole there will be some electric field, that means there will be some electric intensity around this dipole, and we will calculate that electric field intensity on axial line and equatorial line. So there are two cases. First we see what is a axial line. See, a line passing through the two charges and the center of dipole is called axial line. This is called axial line. Okay. A line passing through the center of dipole and perpendicular to the length of the dipole is called equatorial line. Equatorial line. Now we will calculate the electric intensity on a point which is there on axial line and on another point which is there at equatorial line, on equatorial line. So first we will see how the electric intensity at a point on the axial line will be. Okay. First, here in this diagram, this is a dipole minus q and plus q. A dipole separated with a distance of 2a, and a point is considered at a distance of r, small r, from the center of the dipole. A point P is considered at a distance of r from the center of the dipole. So why we have considered a point here means, now we are calculating the electric field intensity due to this dipole on the axial line of the dipole. That's why we have considered a point here. Now see here, at the point P, the electric intensity due to this charge, we know the formula for electric intensity due to a point charge. We have taken that in the previous class. We have seen what is the formula. That formula we will apply here. E bar, electric field, is equal due to a point charge is equal to 1 by 4 pi epsilon naught q by r square. Here see, I have written r plus a. This is electric field due to the point charge minus q at the point P. See, what is the distance between the charge minus q and point P means the distance r from the center of the dipole and the distance a. The total distance is 2a and the distance, half of the distance is a. That means r plus a is the distance between the charge minus q and the point P. So the formula here, see, the original formula is E bar is equal to 1 by 4 pi epsilon naught by q by r square. This is the original formula, where r is the distance from the point charge. Here in place of r we have written r plus a, that means a plus the distance r. Next, the electric field intensity due to this positive charge plus q on at point P. Okay, electric field intensity due to this positive charge at point P. So here, what is the distance between plus q charge and p? That means this r minus a, r here, the distance r from dipole center to point p minus a gives the distance of positive charge plus q to point p. This is why I have written this at this point r minus a. Okay. So here, these are the two electric intensities acting upon at this point because of the charges minus q and plus q. So what is the net electric intensity because of this dipole? See, net electric intensity, that is E axial, point on axial line, is equal to, okay, E plus q plus E minus q. That is equal to, here E minus q is in place of, here we put minus because see, minus, this is plus. Here why we put minus here means, see, the dipole moment of this electric dipole will act from minus charge to plus charge. So the direction of dipole moment is from minus charge to plus charge. The electric field due to this negative charge will be in the direction opposite to the dipole moment. This is dipole moment P bar, and the electric field due to this negative charge will be opposite to the direction of dipole. That's why we have taken this minus sign in front of this electric field. So P cap is the unit vector of dipole moment. Okay. So here this can be written as 1 by 4 pi epsilon naught, okay, into q by r minus a whole square plus here there is minus, right? That's why we write minus 1 by 4 pi epsilon naught, okay, q by r plus a whole square, okay. Into P cap. So if you take q by 4 pi epsilon naught as a common factor, q by 4 pi epsilon naught as a common factor, what we can write is r minus a whole square minus 1 by r plus a whole square into P cap. This is a unit vector of dipole moment of a dipole. See here. If you take the common factor of these two, r minus a whole square plus r plus a whole square, so this becomes okay 4ar. I have taken a direct step. This means r minus a whole square, this goes to r plus a whole square, okay. So when you go take an LCM of this, and this becomes r square minus a square whole square, okay. This r plus a whole square minus r minus a whole square will become, and the r square a square terms will be cancelled, and this will be written as in this form. You can take the LCM, and you can, if you simplify this one, you will get 4ar. Okay. So if you want to know how this has come, we will take another step here. Okay. So in another step, we can consider See, I will show you how this part has to simplify. Okay, r square minus a square whole square. Yeah, but what happens is this r plus a will go to this side, r plus a whole square. Okay, then minus r minus a whole square. Okay, I am telling you the simplification of this, how I have written directly this form. Okay, now what happens, r square plus a square minus plus 2ar. Okay, r square minus a square plus 2ar by r square minus a square whole square. So this term in the brackets I am simplifying here. Look at this, r square a square gets cancelled, so that becomes 4ar by r square minus a square whole square. That's what I have written it directly. So you can, if you want to note down, you can just take a note of it. Okay, the simplification. Okay, so here look at this, q 4ar 4 pi epsilon naught, these terms can be further simplified. Okay, see, we write q by 4 pi epsilon naught. I will write 2ar as 2a into 2r by r square minus a square whole square. Okay, p cap. Okay, see here, if we can say that 2a, length of the dipole 2a into q, we can consider it as the dipole moment, right? What is the dipole moment? Dipole moment of a dipole is equal to charge and the distance between the two charges of the dipole. Here in case the distance between them is 2a. So q 2a. Q into 2a will become the dipole moment. Okay, q into 2a I will write as dipole moment. See here, r square minus a square. Okay, if the distance between the two charges is so small compared to the distance r, the distance between the center of the pole to the point. See, if the distance a is so small compared to the distance r, then this can be written as into 2r. See, the condition is r to the power of 4. That means that a is far less than r. A is far less than r. So in this case, look at this, the dipole moment p into 2r by r power 4. Okay, so here this is, again you can write this equation as 4 pi epsilon naught into, so 2 p into r by r power 4. So we can cancel r with some in the denominator. So that can be written as, see, this can be written as 2 by 4 pi epsilon naught into p by r cube. Okay, so this is finally simplified to this value. The p cap is also here. Okay, so the final formula, so the E axial here, After simplifying step by step, the E axial, that means the electric intensity on axial line due to a dipole, can be written as E axial is equal to 1 by 4 pi epsilon naught into 2 p by r cube p cap. This is the electric intensity on the axial line of a dipole. Please note, take care of the steps I have written on the board, and you can follow these steps and you make a note of it if you want. Next, we will consider the electric intensity on equatorial line. What is that? Equatorial line. Equatorial line of a dipole. See, we already discussed what is an equatorial line. The line passing through the center of a dipole and perpendicular to the length of the dipole. Okay. See, here there is a dipole which is having a distance of 2a between them, minus q and plus q. See, the center of the dipole is at O. So the equatorial line, which is passing through the center of dipole, it should be a straight line. This is the equatorial line, perpendicular to the length of dipole and passing through the center of the dipole. This distance is A, this distance is A. So the distance between the two charges is 2A. The distance between the two charges is 2A. Now we will consider a point P here, so that we will calculate the electric field intensity at this point on the equatorial line due to this charge minus q and this charge plus q. So what is the net intensity here at P? We will calculate now. What is the distance, direct distance between point P and charge minus q, and the direct distance between the point P and the charge plus q? So if the distance between the point and the center of the dipole is r, this is r, this is a. So due to the property of triangle, so this is the distance of base and height. What is the distance of this hypotenuse? Means r square plus a square, right? So the electric field, the making an angle with the dipole, axial line of the dipole, theta. The distance is making an angle theta with the axial line. So here, if you observe, the electric intensity will be acting on the point charge in this direction. Suppose this is A, this point is B, this is B, point A, this is point B. So the electric field intensity due to this charge will be acting in this direction. So here the electric field intensity due to this positive charge will be acting in this direction. So then we can make the net resultant intensity by considering the angle of the components here as, see, this is theta, and this by symmetry, this is also theta. right? So see, by the symmetry of a triangle, this angle is theta, and at the same time this is also theta. And when this line is making an angle here, and at the same time it makes an angle of theta also here. Okay, so when this component, this electric field from P to A in the direction of PA, this electric field, because of minus charge, will act in the direction of PA. This electric field due to this positive charge will act in the direction of BP. Okay, so when we take a resultant electric field here, and there will be a resultant electric field, we should make this into two components. Okay, and this is E minus Q. If you say this is E minus Q, and in this direction this is E plus Q. See, the resultant direction in this direction will be E minus Q plus EQ. Okay, and the vertical components, see, this is E minus Q cos theta. This is E minus Q cos theta, comma EQ cos theta. Both will act in this direction. If you take two components of this electric field in this direction, this is E minus Q cos theta, this is E minus Q sin theta. And again, if you take two components of this electric field due to this positive charge in the direction of BP, so this is EQ sin theta. So EQ sin theta, EQ cos theta. This is E minus Q sin theta. E minus Q sin theta. Okay. So these two components of these these components will be added up, and the vertical components will be cancelling each other, because this is acting in this direction and this EQ sin theta is acting in the upward direction. So these two will be cancelling each other. They have a null effect on the point P. What is the net electric field at this point? Means E minus Q cos theta plus EQ cos theta. Okay. See here. What is the electric field due to this charge? That means E minus Q is equal to 1 by 4 pi epsilon naught Q by, what is this distance? Root of R square plus A square whole square. Right? That means it becomes 1 by 4 pi epsilon naught Q by R square plus A square. Okay, R square plus A square. So electric field due to this positive charge, that is E plus Q is equal to, same we can write in this form, 1 by 4 pi epsilon naught Q by, what is the distance? This distance is also same, R square plus A square, and this distance also same, root of R square plus A square. Whole square. So here both the electric field intensities are same along the directions PA and BP. Okay. Now, what is the resultant electric field at this point here? E minus Q cos theta, EQ cos, both will be added up. And this net electric field intensity is opposite to the direction of dipole moment, right? Opposite to the direction of dipole moment will be in this direction, and the net electric field is in the opposite direction to the dipole moment. So here we can write E equatorial is equal to minus of E minus Q cos theta, okay, plus E Q cos theta P cap. This is a unit vector of dipole moment, okay. So here we can write, see, E minus Q, EQ are same here. That means we can write minus 2E minus Q, okay, cos theta into P cap. Okay, see here again minus 2. What is E minus Q here? 1 by 4 pi epsilon naught Q by R square plus A square. Okay. See, what is cos theta? Here, what is cos theta? Cos theta, if you observe this triangle POB, cos theta is adjacent side by hypotenuse. That means A by root of R square plus A square. A by root of R square plus A square. Okay, into P cap. So here, if you observe this one and simplify to the next level, this becomes minus 2A into Q by 4 pi epsilon naught into, see, this will become R square plus A square whole power 3 by 2 P cap. Okay. R square plus A square to the power 1 into R square plus A square. This becomes root, means R square plus A square to the power of 1 by 2. Okay. So I have written R square plus A square whole power 3 by 2. If you observe here, 2AQ again, we have seen just now in the axial line case, 2AQ is nothing but dipole moment. Dipole moment is equal to the distance between the two charges and multiplied with the charge of the dipole. So here we can write this as minus P by 4 pi epsilon naught. See, 2AQ I have written as dipole moment P. Here, see, R square plus A square. If the distance A, this distance, is so small compared to the distance between the point and the center of dipole, that means the distance of the point on the equatorial line from the center of the dipole R is very small. That means when the distance A is compared to R is very, very small, that means the condition is A far less than R. A far less than R. We can write this term as, if A is far less than R, we can write this term as R square whole power 3 by 2. We have dismissed this term. We have neglected the term A. Okay? So this is the electric intensity on the equatorial line. So with this we can write the final formula as, see, here we got the final equation. That means we can write E equatorial is equal to minus 1 by 4 pi epsilon naught into P by this 2 and 2 will be gets cancelled. This R becomes R cube into P cube. Okay. See the minus sign here. The minus sign here indicates that the net electric field intensity is along the left side. That means opposite to the direction of dipole moment. The minus sign indicates the direction of the net electric intensity on the equatorial line of a point P. So this is how we can take the calculations on the axial and equatorial lines. So we can find out the electric intensities due to a dipole. So please take a step-by-step note, and if you want to get any clarification, you want to know how these are useful in further calculations, you make a comment in the comment section and I will reply in the next class, so that the interactive session will become what you require, what you need in the next classes. I can understand by your comments. Okay.